So this is problem 11. 11 reads, the position function of a snail moving along a straight path is given by this function. St for position is t minus 3 divided by t plus 2, where st is the distance in centimeters from the starting point after t minutes. Find the acceleration of the snail after 1 minute. Okay, so we need to recall something. The derivative of the position function is the velocity function. So you take the derivative of st, you're going to get vt, which is the velocity function. Now if you take the derivative of the velocity function, or if you take the second derivative of the position function, you'll obtain the acceleration function, at. So the derivative of et is at, or also the second derivative of the position is also at. So simple. So now all we have to take is the first derivative of this. So that would give us the velocity function. So s prime t is equal to, using the quotient rule, we're going to obtain that we have 1 times t plus 2 minus 1 times t minus 3 divided by t plus 2 squared. That's s prime of t. We have t plus 2 minus t, so t minus t, let's just rewrite this, t plus 2, distribute the negative, that's minus t, that's plus 3, minus a minus, plus 3, divided by t plus 2 squared. Okay, t cancels with this t, we obtain 5 here, so s prime t is equal to 5 divided by t plus 2 squared. So this here then is the velocity. dt is then equal to 5 divided by t plus 2 squared. So this is vt. Alright, but we need the acceleration. So again, take the derivative of the velocity. So e prime t, again, using the quotient rule, derivative of the top here is 0 times t plus 2 squared minus the derivative of the bottom. It's going to be 2 times t plus 2 times 5 divided by the bottom squared. So that would be t plus 2 squared, that's to the 4th. So b prime t then is equal to, that's 0, 2 times 5, that's minus 10, minus 10 t plus 2 divided by t plus 2 to the 4th. Now we said that the derivative of the velocity is the acceleration, so therefore we have the acceleration function now. That's just this. By the way, t plus 2 cancels with t plus 2 here, so we're left with negative 10 divided by t plus 2 to the 3rd. Alright, now we want to find the acceleration of the snail after 1 minute. So t is time, so 1 minute is the time. So then we want to evaluate a of 1. So it's going to be negative 10. 1 plus 2 cubed, so that's negative 10. 3 cubed, 3 times 3, 9. 9 times 3, 27. So we have negative 10 divided by 27 as our answer. That's the acceleration of the snail after 1 minute. Okay, so the important thing is knowing the derivative of the position is the velocity, and the second derivative of the position is the acceleration, or the derivative of the velocity is acceleration. Once you have that, evaluate 1 into the acceleration, and you will find the acceleration. In this case, it's negative 10 divided by 27.